Welcome! In this video, we shall introduce the method of Lagrange multipliers in solving constraint optimization problems. Let us illustrate the method once more with the second example. We want to find the maximum and the minimum of the function f of xy equals to x squared plus y squared, subject to the constraint equation x squared plus xy plus y squared, which we denoted it as g of xy equals to 3. So first, we would like to find all the first derivative of the function f of xy and the constraint g of xy. And then let lambda to be a parameter, and we would like to solve this system of equation, which in our case gives these three equations. Now there are three equations, and we would like to solve for the unknowns x, y, and lambda. Note that there is no systematic way for us to solve the set of equations we obtained when we compute the partial derivative. In our case, we observe that we can use the equation 1 and 2 to form lambda equals to 2x over 2x plus y and lambda equals to 2y over x plus 2y. All together gives the equation 2x times x plus 2y equals to 2y times 2x plus y. Solving this equation gives x equals to y or negative y. We have made use of this equation 1 and 2 to get x equals to y or negative y. Now substituting each of the case into the equation 3, if x equals to y, then substituting to equation 3 gives when x equals to 1, we have y equals to 1, or when x equals to negative 1, y equals to negative 1. Whereas if x equals to negative y, then solving for equation 3 will get these 2 points. Now altogether we have 4 possible extremum points, which is displayed here. Now we want to find which of the points are the maximum, the minimum points by checking their output values correspondingly. So for the first 2 points, they give an output 2, whereas the third and the fourth point gives an output 6. Therefore, by comparing these output values, we notice that the function f has a maximum value of 6, which occurs at these 2 points, and it has a minimum value of 1, which occurs at these 2 points. The following are the graphs of the objective function and constraint equation in this example. Again, we restrict our variables x and y to satisfy the constraint equation x squared plus xy plus y squared equals to 3, which is an ellipse in our xy plane. And then when we consider their corresponding outputs on the objective function fxy equals to x squared plus y squared, it will be those points which is along this yellow path. The method of Lagrange multiplier helps us find the maximum and the minimum of this function under the restriction. In our example, we obtained 2 maximum points and 2 minimum points on this yellow path.